Before we look at sine function though, I want you guys to remember quadratic functions. In quadratic functions, there was an a in the beginning. It was a bracket x minus h close bracket squared plus k. What did the a value do to a parabola?
Opens it up or down.
Good. It made a smiley face or a frowny face. What else did the a value do?
Tells you if it's negative or positive.
Okay, and the positive is open up, the negative is open down. It can also do something to the shape of my parabola.
It tells you the stretch or compressions.
Perfect. It told you if it was stretched, if it was like kind of stretched long and skinny, or if it was compressed so it was wider. Guys, take a look at A here in sine function. It does the vertical stretch or compression, and it also does the reflection. So that should be fairly easy for us to remember from quadratic functions because it looks very similar here. The extra thing that we have though is that the absolute value of A tells me the amplitude. Absolute value means don't look at the positive or the negative, just what's the value there. Okay, so you're gonna have to separate the sign from the value. If a 2 is there, the amplitude is 2. If a -5 is there, the amplitude is 5. If a 2/3 is there, the amplitude is 2/3. Okay, if it's a -3/4, the amplitude is 3/4. Then we have the rest of this equation here. Before I get into the k, the d, and the c, you guys will remember in quadratic functions, in brackets, we had x minus h. And what did the h do to my vertex? How did it transform or shift my parabola?
Was it like one of the points in the vertex? Like where
Mm-hmm.
you put the vertex?
Mm-hmm. And did it shift along the x-axis or the y-axis? The x minus h, the h value.
X?
Yep, it moved it left or right along the x-axis. Guys, take a look at this d variable, which is here with x minus d. It shifts it left and right. Okay, so that's similar to like the h value of quadratics. So it's in brackets with x, it's shifting it along the x-axis, left or right. Okay, and same thing as quadratic functions. It's going to go opposite to the sign in the equation. So if d is less than 0, if it ends up being a positive value in here, because minus and negative is plus, if it's a positive, it's going left. If it's a negative in the bracket, it's going right. So very similar to quadratic functions. Okay, if it's a positive in the bracket, it's going left. If it's a negative, it's going right. And then you guys will remember in quadratics, we had a plus k on the end. What did the k do to my parabola? How did it shift or how did it move my vertex?
The up and down the y-axis?
Fantastic. It moves it up and down the y-axis. Take a look at this plus c. It's going to shift it up or down along the y-axis. And if it's greater than 0, if it's a plus, it's shifting up. If it's less than 0, if it's a negative, it's shifting down. The only extra thing we have with sine function is this k value in front. And the k value can actually change the period, so the amount of time it takes for the pattern to repeat. So it actually horizontally stretches it out or compresses it. So it's like a little bit like an accordion. So if you pull it out and stretch it, then the period is going to be longer because you've stretched it out. If you compress it, if you take the accordion and shove it in, it's going to make the period shorter because you've pushed all the points together. So we have a vertical stretch and compression, but we also have a horizontal stretch and compression. And there's an equation here, a nice easy equation that if you take 360 and divide it by the absolute value of k, again, don't take the sign, just the value, it will tell you the length of the period. So the horizontal distance it takes for the pattern to repeat. One thing I need to mention is now that we're talking about just sine function, we're going to be working with radians and not degrees. Radians are based on a circle. So earlier, like I was saying, if I'm standing at a 45-degree angle, but then I turn a full 360 and come right back to my same starting point, then it's going to look like I'm still at 45 degrees, but I'm actually 360 plus 45. And then I could do it again and come back here and add another 360 and be at the exact same position. So it's going to be based on radians, not degrees. But don't worry, we're going to see that here in a second. All right, enough talking. Let's play around with this. I'm going to throw into the chat the Desmus graphing calculator I want you guys to use today. And all we're doing is just investigating what does A do, what does K do, what does D do, what does C do. And we're hoping to just get a really good feel for how sine function can be transformed. So the first equation we're going to look at is y equals -1/4 sine x. If I just go back to my chart here for a minute, all I'm doing is looking at my A value. Now in this one, it's -1/4. So the vertical stretch or compression is by the factor of A, and it can also be reflected. Because it's -1/4, it should be reflected, and then we have to see how the stretch or the compression works. So I'm going to put into this equation an A value of -1/4. Hopefully you guys can see my graph here. This is what sine function looks like with nothing changed. Initially, it starts off with an A value of 1, a K value of 1, C is 0, D is 0. So this is how sine function looks without anything happening to it. You can definitely see it's a repeating pattern, okay? And you can see that the height and the minimum and the maximum, it goes up 1 and down to -1. Okay, you can kind of see the highs and the lows there, okay? What we're going to be doing is making A -1/4. So you can either type it in, or you can grab the little slider and slide it to a -1/4. What do you guys notice happened to my graph? So let me change it back to 1. Okay, and now watch what happens to my graph. So right now it's going up to 1, down to -1. I'm going to change my A value to -1/4. What's the highest that it goes?
0.25.
Exactly. It now only goes up to 1/4. And what's the lowest that it goes?
-0.25.
Good. So I've just changed the amplitude. I've smashed it. I've shrunk it. It's like it's compressed. It's now, it was going from 1 to -1. Now it's only going up to 1/4 down to -1/4. So it's smashed. Now you might not be able to see the negative very well yet. This actually has been reflected, but it's like, how do I know? It's just a wave. Watch what happens. Watch my graph when I take out the negative sign. So I'm just going to make the A value +1/4. Okay, I'm going to subtract the negative sign in 3, 2, 1, go. What happens with the negative sign?
Doesn't it like mirror it or something?
Exactly, it's mirrored. When it's a positive, look at the 0, it's going up from 0 to the right. As soon as I put in the negative, now it's going down from 0 to the right. So it's a mirror image, which may not seem like a big deal, but it is actually changing from my 0 point. It's going to start off dipping down first and then coming back up. Whereas if it's a positive A value, from 0, it's going to start off by going up first and then back down. Okay, so your A value, if it's a negative, it's actually flipping the sine function. A positive is going to start from 0 going up, but if I put in a negative value from 0, it's actually going to go down. And then the 1/4 smashed it. So if I go back to my notes here, hopefully you guys can see that it was reflected like a mirror because it was a negative A value, and it's been compressed because I smashed it, only made the amplitude 1/4 of what it was initially. And if I look here, the absolute value of A in this question is 1/4. So I took the amplitude, and the highest it's going is 1/4 and the lowest it's going is 1/4. Any questions? Oops. Okay, if you're going to graph this, I would start off just putting a couple of points. So for sure, it's going to cross at 0. And then because it's a negative, it's going to start by going down. And I'm just going to actually look at my graph here and see. You're going to go down, up, and down again on your graph. So let's see here. It's going to be a little bit tricky to repeat this. If you actually just go by the 0 points, hopefully that is going to give you guys enough points to go through this. So 360 is a whole rotation. So I'm just going to go by 180s and 360s. And I'm only going up a quarter. So my highest point that's going to go is like very, very low and very high. So it's going to go down and up. Oops, down. You don't have to worry about graphing these guys because you're actually going to, I'm going to give you the graph or you'll use Desmus. So don't worry about that. And up. Ooh, and back down. Or a screenshot from Desmus if you're like, this is not going to work. I'm going to just type into my notes here that the negative, so negative A value is reflected. So from 0 goes down. And the 1/4 is, equals compressed. And the amplitude is a quarter. Thankfully, A being our value makes sense that it's amplitude. Any questions on that? I'm less worried about the graph. I'm mostly concerned about, can you look at the equation and describe it? Because that's where you're really going to know if what the graph looks like, and you can interpret a little bit better. Questions? I'm actually going to grab from Desmus so our notes are complete here with this one. I'm going to cheat here, and then you guys will have the graph in my posted notes. Okay, let's look at your next one. Your next one is y equals 4 sine x. I want somebody to try describing to me, what do you think this sine function looks like? A is positive, and now my value is 4. What do you think it's going to look like?
I have a question.
Yeah.
You know how we just like walked over the whole formula before we started this? Are we only doing this one section, then we're gonna like add on to it, or is this what it's gonna be like?
This is the majority of this chapter, is interpreting the equation. So we have the only, so Lauren, we have this, and then we have how does this apply to word problems, and that's it. So this is the majority of the chapter.
But like on the last page with that big formula on the top, it's not going to be like plug in the numbers and add and subtract and solve.
No, there's no calculate. Well, there's one thing that you'll do to figure out a maximum tomorrow. You'll just plug in a number and use your calculator. But no, I'm going to give you the equation, and I'm going to I'll either say which graph relates to this equation, or I'm going to describe the sine function and say what would the equation be to make a sine function that has an amplitude of 6 or is reflected. So it's basically interpreting this equation.
Okay, thank you.
You're welcome. So guys, what do you think this second one's going to look like? This is problem number 2. What do you think it's going to look like? First of all, A is a positive, so do you think it's been reflected? Will it be a mirror image if A is positive?
Yes, I think yes.
Actually, if A is positive, it is not a reflection. It's going to be from 0 starting by going up to the right. It's only going to reflect down if it's a negative. So this one is not reflected. Reflected. So from 0 goes up to the right. And A is a value of 4. So what do you think the amplitude is? It's going to the highest and the lowest value going to be?
+4 - 4.
Perfect. Okay, do you think then, so normally it goes from 1 to -1. If it's going up 4 and down 4, has that been stretched or compressed?
Stretched.
Perfect. So we're going to try this on Desmus now and see if we're right. So we're just going to change the a value to 4. That's all we're doing in this question on Desmus. So I'm going to get rid of that -1/4. Here is it with a 1, and now what happens with the 4? Okay, it's from 0, still going up and then down. So it's still going in the same pattern. Let me make it a 1 again. So see, the 1 from 0 is going up to the right. If I change it to 4, it's still going up from 0 to the right. But the highest to the lowest is now 4. So the amplitude is 4. Okay. Any questions on this one? Okay, I'm going to just drop this into our notes. If you guys wanted to use the amplitude equation from yesterday, what's 4 take away -4 divided by 2? What do you guys think? What's 4 take away -4?
8.
8. And then what's 8 divided by 2?
4.
4. So the amplitude literally is just the a value, or if you want to do a quick calculation, 4 take away -4 is 8. 8 divided by 2 is 4. So it all does really line up, but we're going to be just using the equation to interpret these things. Okay, let's try another one. Okay, first of all, let's go back to the original equation. This -30 in here, is this A, is it K, is it D, or is it C? It's in brackets with X. What do you think?
Can you go back for like literally 2
Sure.
seconds?
To which one here, Lauren? This one?
Yeah.
Or, okay, yeah,
Thank you.
you're welcome. This -30, is it A, K, D, or C? It's in brackets with X. So what do you think?
D.
D. So it should shift it left or right. Now, please remember, it's very much like your quadratic formula. It's a -30. So did this shift it left or right?
Right.
Right. Good, Nicole. So if I grab Desmus, this should shift to the right. So I'm going to change my D value. I'm going to make A back to 1. And I'm going to make my D value 30. So in here, I've just plugged in a 30. Now this may be hard to see. Let me take it out and watch my graph. Okay, so I'm going to go back to 0. So please notice that the graph crosses the x-axis at 0, at pi, at 2 pi. So at every pi, it crosses at 0. So watch what happens when I put in a 30. Can you guys see it shifted off of those points? Hopefully you guys can see that it's shifted. Now you don't have to worry about graphing it, just please know that it did shift. So here it is at 0, and now here it is at 30. Okay, hopefully you guys can see that. So I'm gonna go back to my notes here, and we can just describe this. Let me grab my graph. Okay, so one thing you need to notice that there is no A value in this one. So A is 1. Okay, if there is no number in front of my brackets, it's a 1. So my amplitude is still going up to 1, down to -1. So remember, A is amplitude. So if you're not sure what's your A value, take a look at the graph. It's going from 1 to -1, 1 to -1. So my amplitude is still 1. However, that -30 means that it's shifted right 30. 30 degrees. Okay. Any questions on this one? Maybe actually I'm going to write in here that A is 1, just so we have A equals 1. Amplitude is 1. And the only thing that's happened is it shifted right 30. Okay. So if it's in brackets with X, it's shifting it around on the X axis, left or right. What about this one? I have a +1 on the end. What do you think is happening with this one? Is that A, K, D, or C?
C.
Okay, so what do you think is happening to this one, Nicole?
It's being moved up 1.
Good. Okay, I'm also going to just put in here that A is 1, just so we know the amplitude is still 1. A equals 1. Amplitude equals 1. Okay, and then let's just see what happens if we have a D value and we shift this. Okay, so going back to Desmus, I got to reset everything, make D 0, and I'm changing C to +1. How can you tell that this has been shifted up 1? Let me change it back to 0. How can you tell it's been shifted up 1?
This is not on the X axis anymore.
Perfect. Initially, it was the amplitude was 1 up from the x-axis and 1 down from the x-axis. The x-axis was right through the middle. But now when you add the +1, it shifted up. So now it's actually going from 0 to 2 instead of 1 to -1. So it's shifting it up 1. But here, guys, I want you to pay attention to my amplitude. So max take away minimum divided by 0. What's 2 take away 0?
Oh, so it's supposed to be a 9?
2.
And then what's 2 divided by 2?
1.
1. So my amplitude
1.
is, yeah, good. My amplitude is still 1. It looks like it's maybe not 1 anymore, but when you still take the maximum, subtract minimum, divide by 2, you're still with an amplitude of 1. However, the whole graph has been shifted up 1. Okay. Any questions on this one?
$1. Oh no, it's just 99 cents.
Everyone understands what's happening here?
No,
What's your question, Lauren?
I don't know. I just don't get it. Like, just not yet.
Okay, so you mean just this one, or like transformations in general?
No, just in general. But that's okay.
Okay, hold on. I think you'll get this. Hold on 1 second.
Okay.
We're getting there. So far, we've only been looking at those things one at a time. We haven't looked at K yet. So notice K is not in brackets with X. It's actually in front of X. So we got to just check out K, and then we'll kind of put it all together. So go back to Desmus for a second. And you're changing K. So I'm going to reset all of my sliders. So it was 1, 1, 0, 0. And now I'm going to make K 4. Guys, watch my graph for a minute. So first of all, I've just reset it back to 0. So my highest is 1, my lowest is 1. It's a periodic repeating pattern crossing the x-axis at every pi value. So 0, 1 pi, 2 pi, 3 pi. Watch what happens when I make K 4. This should be like the accordion, horizontally stretching or compressing it. So watch the graph. What do you notice happened?
Compressed.
Yes, it's like I took the accordion and I smushed it in. So, okay, I'm going to change it back to a 1 for a second. If you guys look at normally, how many peaks and valleys do I have between 0 and 2 pi? How many peaks and valleys do I have here?
1.
Good. Now watch what happens when I make it 4. Let's count how many peaks we have from 0 to 2 pi. How many do you notice? 4, and 4 valleys as well. So it's repeating 4 times faster than normal. I've made the highs and the maximums and the minimums repeat 4 times more frequently. So this would be like if we had high tide and low tide 4 times every day, instead of just 1 high tide, 1 low tide every day. Okay, so K is horizontally stretching it and compressing it. Just a quick question. What do you think would happen if I made K, let's say half?
It would be stretched.
Okay, so horizontally stretched. Let's see. Is that true?
Yep.
Yeah, I have half as many peaks and values as normal if I make it a half. I only have 1 peak, literally no valleys. I'm actually making it occur half as often as normal. Okay, so a fraction is going to make your period happen less frequently, but a whole number is going to make your period occur faster, more frequently. So you can kind of play around with that. Like if I make this 7, look at that, how crazy that is. I make it 10, if I make it 100, oh, you can't even tell when I make it 100. It doesn't even fit on the graph. So the higher the number, the more often that pattern repeats. Okay. But the smaller the number, the less often that pattern, that actually looks like almost a straight line. It's so horizontally compressed. Okay. So let me go back to one more with us. Oh, actually I need a screenshot of that. Give me 1 second. Got to make that back a 4 and take a screenshot of that. Okay, there we go. Again, you guys can notice with this one, I haven't changed the amplitude. The highest and the lowest is still 1. It's going up to 1, down to 1, but the highs and the lows are happening 4 times faster than normal. All right, so let me just type in some notes here for a second. So I'm just going to type in A is 1, so the amplitude is still 1. But the frequency is 4. So the max and mins occur 4 times more often. Okay, Lauren, now we're going to kind of put it all together. If you guys want to look at the chart on the very first part of this lesson, it may help you, and I'm just going to type in your notes, okay? So I have an A, I don't actually have a K, but I have a D and I have a C. So we're first going to try to describe what we think this sine function looks like, and then we're going to check to see if we're right. First of all, my A value is -2. What do you think that does to my sine function?
Opens down.
Okay, good. It's going to be reflected. So it should start at 0 and go down from 0. What else?
Stretched.
Okay, good. So my highs and my lows should be twice as high. So it should be stretched by 2. What do you think the x plus 45 means?
That there's 45 peaks and valleys.
That would actually be if there was a k in front of the bracket. I don't have a k here. This is in brackets with x.
Okay, I don't know.
So if it's in brackets with x, it's moving along the x-axis. Do you think it shifted left or right? X plus 45, guys, shift left or right?
right?
It's opposite to the sine.
Left.
Good. So it's shifted left. And then my C value is -2. So what do you think it's done as far as shifting up or down?
Down.
Good. Okay, so let's see. Let's plug this in. We think it's going to be reflected and stretched. We think it's going to be shifted left and also shifted down. So let's just take a look here on Desmos to see if we're right. So we had, I just got to remember my equation, -2, 45, -2. -2, 45, and 2. So A was -2. We didn't have a K value. D was -45. C was -2. Okay, it's kind of hard to tell here whether it's shifted. So I'm going to actually get rid of C and D for a second. With the negative, we said it should be reflected down from 0. So does it go down from 0?
Yes.
Yes. We also said it should be stretched. So the maximum and the minimum should be twice as high as it initially was. Is that true?
Yes.
Yes. Then we said the D value minus, this is the hardest one to tell. You're like, I don't know where it shifted. I know it has shifted. So at least if you know it shifted off of 0, you're fine. But this actually has shifted to the right 45. So as long as you can see it shifted off of 0, you're fine. And then let's see if it shifts down when I plug in the -2. Did it shift down?
Yes.
Yeah.
Fantastic. If you guys can just look at the A, the K, the C, and the D, and just interpret what you think is going on with the sine function. That's what you're playing around with today. Okay, use this online calculator. Check, make a prediction, check what you think is going to happen, and see if the graph is correlating with what your initial guess or estimate is.